Thanks, Richard. Okay, so I'm basically going to talk about the McIntosh graphite. Does that work? Yeah. Okay. Graphite deposit. Graphite was pretty big a few years ago, and it basically went into the shade for a while, and now with all the movement around lithium and so forth, and basically graphite will probably come back again because it's one of the key components in lithium-ion batteries. Basically, just a competent person, forward-looking statement, the obligatory ones. Okay, quickly the outline of the talk will be who Hexagon is, basically the geology of the project, talk about the deposits, exploration, how they sort of come about, and basically what the product or the concentrate looks like, and then a quick summary. Okay, so as Richard said, Hexagon's a junior exploration company. It started around 2011, and one of the gentlemen in here is actually one of the original guys. Basically, the project's up in the East Kimberley. In the map, it's a couple of 100 k's south of the port of Wyndham. It's pretty much next to the Savannah nickel mine, and even closer to its Copernicus nickel mine. It's only a few k's off the Great Northern Highway, and it's right next to the haul road of that Copernicus used. Basically, the project is looking to be a flake graphite targeting the battery and the expandable graphite market. And also, I mean, we've had a look at graphene, but we haven't really focused anything on that. So basically, from some of the work we've done now, we've produced a con of basically 97% TGC, and that's through basically simple flotation and grinding process. As mentioned earlier, the project's pretty close to infrastructure. And as of earlier this May, we produced a PFS, and that PFS was based around the current reported resource of 21.3 million tonnes at 4.5. Obviously, that 4.5 is a little lower to pretty much a lot of the other people, and that was sort of highlighted in that the presentation this morning. That's across 4 deposits, and the main deposit is Emperor, which is where most of the work's been done on. Okay. The geology of the area, it's basically in the Horse Creek Orogen, which is a paleoproterozoic terrain consisting of low to high-grade metasediments, metavolcanics, and basically intruded by basically granites and mafic and ultramafic units. The project sits inside the over here inside the Lambu complex, and that's been further subdivided in 3 terrains, and I'll talk more about that inside the deposit type geology. The other key thing is basically the Halls Creek has had 6 sort of phases of deformation, and especially the introduction of the mafic bodies are pretty important for graphite. Okay. Basically, the geology on a project scale, as I mentioned earlier, there was basically 3 terrains inside the Lambu complex. The project pretty much sits inside the central, which is pretty much the Tikalara metamorphics, which consists of a lot of metasediments, which is pretty much what you need if you're looking for graphite. Some of the other rock units inside there are basically migmatites, paranices, granitic gneisses, and some calc-silicate rocks. Basically amphibolites also, and some of the other intrusives. And as I was talking about earlier with the intrusives and the importance, if you notice, we're basically, the current 4 deposits we have are all pretty much proximal to the Panton intrusion. The grade of the Tikalara metamorphics is sort of generally around amphibolite, but some of the sediments inside there's a few subtle changes where it might have sort of andalusite, and some of the high-grade stuff is sillimanite, which is pretty much where most of our graphite deposits at the moment are occurring. As I said before, the proximity to the intrusion is pretty important. It's probably the contact metamorphism to give that extra push along to produce a better grade and probably a better flake size. Our main deposit, Emperor, is basically a anticline formation, and the structural deformation, we sort of look at that as potentially another reason to promote graphite or flake size inside the deposit. Okay, what the actual graphite looks like. So there's two basically type of graphite mineralization. We've got graphitic schist and we've also got a graphitic gneiss. The higher grade stuff is the graphitic schist, and that's basically inside with a mica and a mica and quartz feldspar. The actual content of the graphite is generally around 5%, and it's quite orientated to the foliation direction. That's pretty much inside that poly section up through there. So the lighter coloured stuff's the graphite. Basically inside the background will be coarse sort of micas, pretty much biotite, muscovite, but also some of the finer sericite as well. These are a couple of key things we need to look at when it comes to processing. Stuff in the bottom, some of the core basically, that's coming from the fold hinge, which is most of the stuff drilled first because it was the closest to the surface. The graphitic schist also has sulfide content, can be pretty high in parts, and there's a fair correlation between sulfides and TGC. And the majority of the sulfides are pyrrhotite, but the advantage of where that pyrrhotite sits is it's actually generally not inside the graphite, it's outside of it. So we can, that's going to have implications for processing down the track. Okay, I might quickly just jump to show you show you what a section of Emperor looks like, and then that'll make more sense in basically those flake size distribution. So as I said earlier, it's pretty much a anticline, we've sort of, most of the drilling's been focused on that because it's basically closest to the surface, and you're working downwards. Okay, so back. Okay, flake size. So obviously pricing, what you're going to get is basically come back to your flake size. So what we've done in the last month is to put a lot of effort into starting to characterise what the flake size looks inside the deposit. So originally the thought was higher the grade, higher the flake size, and also based on that concept of structural deformation promoting better flake size, we thought the hinge zone produced bigger flake. But from the petrology work we've done so far on 60 core samples, which are basically being selected through Emperor across the domains of basically, there's a lower grade hanging wall deposit, which is only about 3.5%. Then there's the main area, which is basically broken up into a west limb, an east limb, and a hinge. And then basically I've just put them all in together. The main thing from that is basically the flake size where it sits inside that Emperor deposit doesn't really change. So whether it's in the hinge or whether it's out in the limbs. So then the other thing we started to look at is basically the grade distribution and how does that equate to flake size. Same sort of thing over here. So even though the grade's changing, the actual flake distribution is not really changing. So there's a reason for that. And that'll be a couple of slides later. Okay, how we went about exploring for these things, well, as was mentioned earlier as well, people went looking for other things in this neck of the woods, pretty much nickel, sulfides and PGEs. And so a lot of work was done, the last 30 years up through there. One of the chaps who floated Lambu did some drilling in the early 1990s looking for nickel, PGEs, and he actually intersected graphite, kept it in his memory bank, and then 20 years down the track, graphite hit the scene as something to be, and away he went. The other thing is basically graphite also being so pretty soft. There's not really much outcrop through there, and there's also, we're not exploring for this stuff using geochemical signatures, it's basically carbon. So that doesn't work. So the system that works best is basically EM. So Hexagon basically flew two lots of surveys, one in 2014, which is a VTEM survey, and one in 2016, an Excite survey. Basically, the image on the top is the latest time, and basically you can see basically the highs are equating to where pretty much most of the graphite is. Okay, the other thing we're also looking at as well is we'll use the late time stuff as our first port of call, but we're also starting to look at some of the mid-time channel stuff, because some of the older stuff, drill holes done in the mid-2000s, people are looking for nickel. Basically, we're hitting graphite out through there, so that's another sort of thing we can look at. So when we're pretty much exploring through here, we're really going to focus on the structural areas through here and here. Basically, that deformation is pretty much caused by a couple of localized intrusives. So that concept of the extra heat promoting flake size. So that's that. Okay, this is just a quick image of, that's pretty much what the stuff looks like. So if I didn't have a conductor, I'd be walking straight over the top of that stuff. The only other thing of interest is probably a little bit more iron up through here. The only other areas we will see outcrop, and it's pretty limited, is basically with the creeks cutting it. And the image on the left is, I sort of did that last night, just starting to process some of the Lancet stuff, basically looking for the intrusives inside it, but also looking for other signatures that might be around some of the deposits. That little blue one in there is actually Copernicus. So, and this sort of highlights down through here, where the conductors are that are pretty good. There's some little subtle changes to purple. Okay, so that was basically what the deposit looks like in the ground, but then we've got to take it out, we've got to process it, and then what does it look like once we've put it through a plant? So there's basically been two processes of producing a con, and the first one was a batch test work, and it was done on around 200 kilos of diamond core from Emperor, and then the second was done on about 2.5 tonne of core from Emperor, which is the other thing. You pretty much need to drill this stuff with diamond core, because if you want to see what the flake looks like, well, you can't smash it with the RC, but you can use RC to look for your extents, and there's not much of a change in, well, there's only probably a 10% step down in actual TGC grade. So if you're looking, potentially it might have repercussions around sort of grade cutoffs, but in exploration it's not a problem at the moment. So it looked like what we got the first lot of the con is basically we still preserved the flake size, so it's still sitting in that sort of large to jumbo, which is going to be pretty important if you're looking at the expandable market. The second con was really drawn towards basically the battery market. So they had it in their minds that they were targeting a con with 106 micron. So they sort of hit that a lot harder. So basically most of that doesn't reflect what's on the top. How the stuff looks like. So it's basically a clean product in that SEM image up on the right-hand side. It's basically saying whatever impurities are in it are sitting out on the edges. They're not internally. So that's positive. So we can produce a clean con. And basically the con's sort of sitting around that plus 97. I mean, you can push it harder for a higher grade, but you're potentially going to trade off your flake. At the moment, some of the second con is in the US being retested. Okay, so this one here is probably one of the more important slides, especially the core, because this is explaining the flake size and why there isn't a change in basically the grade versus a lower grade, and there's not a change in the flake distribution. And that's because pretty much all this quartz feldstar material is sitting inside it. So that's basically, it's 2.9% TGC. But if we were to just isolate that bit out there, it's pretty much like this here, that's 7.5. So these are the things, and that's also reinforcing that across the, so this petrology would have been done on this bit in through here, that the flake is still pretty similar. So what we are looking to do is basically some processing enhancements at the front for two reasons. Basically, improve operating costs, because these things can be pretty expensive, I guess. That's through energy, consumables, plant wear. So we don't need to put this stuff through. You know, that's a big saving, and then we can push our head grade up as well. You know, at the moment we're sort of sitting at 4.5, but you know, maybe we can aim for something that's 7 thereabouts. How we're going to do that is we're looking at processes like ore sorting. So that was sort of touched on this morning on some of the characterization processes through X-rays, maybe spectral logging type stuff. So we've done, you know, real preliminary work on that, but that's something that's ongoing. And then other sort of conventional stuff like spirals, heavy media separation and jigging. Some of those processes might also lead to producing, you know, doing something with the sulfides, because if we've got to put that out into the tails dam and so forth, that's got some environmental concerns. But if we're able to maybe produce a saleable product out of that, well, that kills two birds with one stone. Okay. So what does the properties of the concentrate look like? So we sent some of the stuff to China, and basically they tested some of the con against their reference material to just see if the all these requirements would be met by a hexagon con, and they pretty much are on par or better in parts. So that's pretty positive, and we continue to sort of work on that stuff. Okay, graphene is also one of those things you hear about it in the papers every few months. It's one of these miracle products, I suppose, coming up. So we had a look at it. There's some test work done in the lab, and they basically say, yeah, they can produce graphene out of the hexagon con through basically the 3 methods, which is liquid exfoliation, direct thermal, and electrochemical. They also said potentially that some of the test work might translate into a bigger scale type stuff, but we haven't taken anything further than basically the lab desk. And you know, they're saying basically the purity of the graphite, more efficient graphene. So if we're getting better purity in our con, then you know this can translate into the graphene. And some of the things we're actually looking at to improve the purity inside of these might actually be thermal purification. But with everything, there's a bit of a trade between cost and reward, so we'll see. They also did some test work based on a green method, which is pretty much substituting some of the more nastier chemicals used in the process for more user-friendly ones, I guess. Okay, basically in summary, what the hexagon ore sort of looks like is basically it's pretty clean, fairly coarse mineralogy. So these are all sorts of things that'll make processing better and also produce a better con. We are endeavouring to, so we're starting off with basically a large and a jumbo flake type product, and we're endeavouring to try and preserve as much as that, and that'll lead us into basically the expandables market, which is probably one of those ones which might attract a better pricing than what we could get out of the battery sector. The con basically shows, meets all the requirements for feed into the battery space, and currently at the moment we're focusing on trying to optimize the stuff we have. So, we currently have around 20 odd million tonnes. We have an exploration target that could probably push that 5-fold, but if you're looking to produce to mine somewhere or process somewhere around 2.5 million tonne to produce 80,000-90,000 tonne con, we don't need to spend the money all the time, because basically we're only getting 3 months to drill up there at the moment with the conditions on that side of things. So basically we're spending most of the time just trying to lock down what the stuff, you know, what's the best the con can be, I guess. Okay.
Thanks, Shane.